This video file was recorded in Sabunja University during recitations for the CS204 Advanced Programming course as it was given in the spring semester of 2017.
Now we are going to see some midterm samples, and this is what you should approximately expect for your midterm. Let's go with the first question. You should print out the output. So what is the output of the following program? We have main here. We always start with main. Okay. Follow it because this is usually a challenging question for students. No matter how many times we solve those kind of questions, you still do mistakes and it's confusing. And actually it's not. So we define two integers, m1 and m2. I have declared two integers. This is m1. This is m2. I'm declaring a new IP integer, and this new int will reserve our integer memory, and IP will point to that. So integer pointer IP, it also has its memory box. Let's say its memory is 1000 since, and this is the integer. This is the address 1000. So new int makes this box. The address 1000 is returned to the pointer, and IP is also a variable. It needs memory, so 1000 is stored there. I say the value to which IP is pointing is 41, so this is 41 now. I say that M1 is 8, M2 is 11, so this guy is 8, M2 is 11, and I'm calling the function CRF. This is my function, CRF. I'm sending M1, M2, and IP, but you see, M1 is A here. It's sent as a normal parameter. So I have A, it's an integer. And the A corresponds to M1, meaning that the value of A is 8. Then I expect a reference, B. So I have B here. This is my B in CRF. But this B actually references M2. So what I know M2 is in main, I know it as B in CRF. Then I'm sending IP, and here I'm expecting, what is this, star and ampersand. This is what?
Pointer reference.
Pointer reference. It's called PTR here. It's a pointer, and that PTR is referencing this guy. All right. So we call this function, and afterwards we expect it to return something. This function CRF returns a reference, an integer reference. Now that reference that is going to be returned will be assigned 20 to that value, to that integer, but we will see later on. So we are here at CRF. In CRF we defined another integer pointer which is called C. Let's say we have another memory block which is 1004, the address of that guy, which is put here, 1004, and C is pointing to that. The value to which C is pointing is 3, so this guy is 3. Then I'm defining a new reference D, so this is D. This is a reference, which is equal to B. But B was also referenced, so basically D also references this guy here. Okay? I'm saying D is equal to A. So the value of D, B namely, is equal to A. A is 8, so we assign here 8. We have 8 here. PTR is equal to C. Where is PTR? This is the PTR. But here PTR references this stuff is equal to C. that means that this guy is no longer 1000, it's 1004. So I'm going to write 1004. That means that this poor IP is not referencing this one anymore, it's referencing this one. Okay? And this is interesting. I'm returning the value to which C is pointing. I'm returning C, star C is this one, so let me emphasize it like this. I'm returning this one, but I'm returning it, it's an integer, but I'm returning it as a reference. Okay? So I go here, this is the return value. Instead of this guy, we have this one. And we say, okay, this newly returned reference is equal to 20. So what I'm going to do? I return this one. And we are now in main. So this one, after the CRF is finished, we have this one here. And I say this one is equal to 20. Is this okay? Can I do it? Is this a syntactical mistake or what? It's not, unfortunately for you. What I'm doing is this one. So this memory block, it might have not a name, yes, but it exists there, and its value is 20. Okay? Now I go and I print this stuff. So this will be my output.
Yeah.
Yes?
Once we get out of CRF, doesn't that memory block go away?
Very nice. We have, nice question. So when we finish with CRF, everything that is associated with CRF is going to be deleted. So this PTR will be the name PTR, but not this one. Okay? The names D and B, but not this box. Then we see A. Is any variable referencing or pointing to A? No. It's going to be deleted also. But hey, IP is pointing here, so I'm not going to delete it. Okay? Or if something else is referencing this guy, again, I'm not going to delete it. In this case, I have a pointer plus a reference. I'm returning a reference. So for sure, it's not going to be deleted. It doesn't have a name, but I have an address, but which I can access it. Okay, so we are here now. We are printing this stuff. Main. We are printing M1. What's the value of M1? It's 8. Then I'm printing M2. It's again 8. Then I'm printing the value to which IP is pointing, which is 20. If you don't trust me, then I'm just going to copy paste this code. Copy it. Paste it here. Okay, I'm going to put system pause also. Yeah, and I'm going to run it. You see the output is 8820. So I'm not lying to you. Okay. 8820. And you see why. Any questions? The most confusing part is this one. We return a reference and then we don't have any name for that reference and we assign 20. But this is how it works. Let's go with the second example. Second question. This one, it's an easy one. What is the decimal value of the following bit strings using ones complement? Okay, not twos, but ones complement. Can someone help me? First, is this going to be a positive or negative number? Come on, positive or negative? This bit. It's negative because of the one in the beginning. That's the most significant bit. By most significant, again, I mean the leftmost bit. This one. And how, so this is the most significant or the leftmost bit. How one's complement is working. So I know the sign is going to be negative because of 1. Let me write this guy again. It's 1, 1, 0, 1, 1, 0, 1, 1, 0, 0. Okay. In one's complement, what did we do? We just make zeros 1, 1, 0. So since this is negative, we are taking the complement of it, and we have here 0, 0, 1, 1, 1 becomes 0, 0. This one, 0 becomes 1, 0, 0, 1, 1 becomes 0, 0, 0, 0 becomes 1, 1. What is the value of this guy? Let's use the tricks that we saw last week. So we have here 1, 2, 4, 8, 16, 32, 64, 128. This is equal to 128 plus 16 plus 2 plus 1, which is how much? It's 147. So that number is 147. Is that true? Minus 147, because of the one in the beginning. This is it. The second one. Try to understand it and... Okay, we don't have time for you to understand it. We have 2 bits. With 2 bits, how many combinations do we have? 4 combinations. Let me write all of them. 0, 0, 0, 1, 1, 0, 1, 1. We are using 2's complement, always, whether it's unsigned or whatever. When I have 0, for unsigned, it's always positive. For 1's and 2's complement, if I have 0 in the beginning, it's positive. If I have 1 in the beginning, it's negative number. So, I want to find the overflow line. What does that mean? The overflow line means the following. I start from here. As I go down, I should increment it. So this is 1, this is 2, this is 3, this is 4. This is how it works. If I go upwards, the numbers are decremented. But there will be a line, which is called the overflow line, where the rule is going to be broken. Okay? And we should find it. But first, let us see what does... So 0, 0 means 0, actually. 0, 1 means 1 in 2's complement. 1, 0. What does it mean in 2's complement? If you don't know, let's go. This is 1, 0. This is how you convert 2's complement into normal decimal number. I take the complement, it becomes 0, 1. Then to this 0, 1, I add 1, which is 0, 1 plus 1, which is how much? 1, 0. 1, 0 is how much? Minus 2. Actually it's 2, but since this is a negative number, this is minus 2. What this guy should be? Minus 1. Let's check it. If it's not minus 1, there's a mistake. So 1, 1. This is our number. We take the complement of that guy. We have 0, 0. To this 0, 0, we add 1. What do we get? 0, 1. Which is 1. This is minus 1. Now this is how numbers work. If we go from up to down, numbers should increment by 1. So yeah, 0, 1. 1 plus 1, 2, but hey, I have a mistake. Here, minus 2 plus 1 minus 1, it's okay. But there is only one line where that law is broken, and it's here. Or minus 1, if I go from down to up, minus 1, minus 1, minus 2. Minus 2, minus 1, this should be minus 3, but it's not, it's 1. Okay, 1 minus 1, it's 0, it's working. So this is our overflow line. It always exists. Since we have 2 bits, that means 2 to the power of 2. This is the number of bits. This is 4 combinations. And usually, minus 2, 1. Okay? This is the range we can represent with 4 bits. You assume that 0 is a positive, in a sense. Although it's not. Okay, let's go with another example. The 5th one. Okay, this is it. Try to understand it while I'm erasing the board. You didn't understand it, I suppose. Okay, let me go with it. What we have is the following. We have iterators and recursive functions here. What are iterators? Well, let's say that we have a class which is called, it's not shown here, but I would just want to remind you, linked list. As a private data, as you remember, and we have done it several times during the scope of CS204, we have the head of a linked list. It can be a doubly linked list, a simply linked list, or whatever. Let's say it's a simply linked list. We have some data here, the info value. Let's say those are integers. It can be anything else. So we have 5, 7, whatever, 9. Of course, we have here some public part, but we don't care about it. What we care that here we have a friend function, which is called, let's say, linked list iterator. And this linked list iterator, since it's friend, it can see the private data, helps us to iterate through this list. So basically, we have another class, which is called linked list iterator. As private data, we have, let's say, a pointer, which is called current node. And it's a pointer to one of those, to a node. As public data, you remember what we have here. We have initialize. Initially, when we create an object of linked list iterator, it takes usually a parameter of a linked list as a parameter. Its constructor takes a parameter of which is linked list. And usually we call the function initialize when we want to try to go through it. And this initialize points to the first node. Initially it's 0, but when I call the initialize function, it points here. It can access it since this is friend function. Then I have a function which is called next, if you remember. Next means that this guy from here goes here. Okay. Then it's the function called current. Was the name correct? Yes. This function current prints this 5. So we are pointing to a node. The function current returns the value of its node, the info value, 5, 7, or it might be character, string, whatever. Finally, we have another function, if you remember, which is called hasMore. Let's say we want to print this list here. So we print 5, then 7, and so on. Eventually, we will come to 9. Okay? So hasMore returns false when this current node points to null. If it points to something else, which is not null, to null, it returns true. What you are asked here is the following. We have a function which is called print recursive. It takes an iterator, which is called ITR in our case. This is the name of the object. And you should print this list in recursive order, having in mind those functions here. Maybe you don't have to use all of them, but some of them. Namely, it's stated here that this function has this class has the functions initialize, next, hasMore, current, or whatever. And also, you should assume that in the beginning, current node points to the first node of the list. And you should print this list in recursive. What does recursive mean? Somewhere inside this function, it should call an instance of itself. So, how are we going to do that? Any idea? If what? When do we return? We don't print anything. We are over. Yes? If hasMore what? Is false. Exactly. So I'm writing the function. It's trivial, as you can see. It's not that hard. So this is my function called void. It's void because I'm printing. Print recursive. I'm taking an iterator as a class. And I'm checking if I assume that, again, current node is initialized here. Okay, but head can be an empty list. That's why initially it might be empty. So if iterator has more is equal to false, then return. Okay. Else, what do I do? I print this one, and I recursively call this function to print that one. So how do I print this one here? What should I use? Exactly, but since I'm printing, I'm using cout iterator point current, which returns this 5, 7, and so on. So we are done with one more line. Then what do? We make this pointer to go to the next one. Okay, so we just say this iterator point next. This pointer now goes to the next node. And now the recursive part comes. What should I do? Call the function which is called print recursive. So print recursive with what? With the iterator. Okay? So it starts from 7 and so on till the end. You will have the solutions. So these were the lines that you had to write. Okay? Clear? Straightforward, I would say. Return always. So when the function finishes, always when you have return, you finish. In this case, what is the expected return value? Nothing. That's why you don't return anything. Okay, you might have 1,000 of lines, but if you have return here, the function finishes immediately. Okay, I'll give you 2 minutes of break, not more, even 1, and we will start with the second example of midterm. Okay, don't go away, stay here. Question?